All right, in the last video, we put together a cluster on our PC and we installed a few tools like this one you can see here, which is K8s, and kubernetes, kubectx, Helm, and of course Minikube. So now we're going to move on to actually creating assets inside of the cluster. Now I've prepared a few files already just to make this more expedient. I'm not gonna, make you look at me writing code. I know that's hella boring. So we're gonna take a look at what's already here. And today we're gonna focus on the cluster. So we have two folders here. We're gonna look at Postgres in a future video, but let's take a look at cluster first, right? So what do we have in here? Well, we have a Helm chart. Now let's talk briefly about what a Helm chart is. But to do that, I'm going to pull up Visual Studio Code. All right, so here we are in VS Code, and I want to take a look at the Helm chart and just give you like a brief description. In a previous video, I told you that a Helm chart is a way to group a bunch of assets together that you want to install at the same time. Now, they're not installed at the same time. They're installed in order. Obviously, you can't create a config map if you don't have a namespace, and Helm takes care of that. It has like a default order that it installs things in. But the very, very basic way to define a Helm chart is to create a new folder, in my case, cluster, create a new file named chart.yaml. Or YML, if that's your flavor. Either one works. And make sure that chart was a capital C. And then in there, you just need a couple things. You need the API version and you need the name. I don't believe you need these other ones here. I just like to put them in for future reference, especially if I'm working on a team. Versioning is important. Now, if you're using the Helm CLI tool and you ask it to generate a Helm chart for you, it's going to create like a giant file, and you don't need everything that's in there. There's a lot of placeholder stuff in there. Honestly, I like to keep my charts lean and simple to understand. Not everybody is going to know how to use Helm, what Helm charts are like. It's better to just have a simple key value pair file that people can just be like, oh, this is the key and this is the value, right? Instead of having a whole bunch of like sub values and all this other stuff. So I like to make these by hand, but you can also use Helm to auto generate them. You may or may not need a values file. In our case, we do need one. I have the namespace and the app label and other things that are in here. We're going to go over these when we look at the templates. So let's finally start looking at the templates. And these templates are exactly what you'd expect to see from just a regular Kubernetes, Go template. But the only difference is that it's got these curly braces with dot values, dot, and then the property. So you can see that this dot values is essentially a kind of a pointer that refers to this values file right here. And you can see that I have the namespace and the app label, which is what we were looking at here. So these are they're just references. When we say Helm install, it'll basically replace everything in these curly braces with the values from the values file. We have 4 files. First, we have the namespace. We have limit ranges and a resource quotas, as well as a config map. Config map is a set of key value pairs that you can reference later inside your deployments or stateful sets or whatever. It's essentially configuration for your applications running in the cluster. The namespace is it's kind of like a namespace in C#. It's just a grouping of assets under one umbrella. The resource quotas are a way to define limits for a namespace. In our case, we create a namespace here, and the namespace is called homie, and that's what we're creating here. And then we're saying, hey, for the namespace homie, create these limits. And what these are essentially a total limit for the entire namespace of how much each pod can request. So if you have a pod A that requests 0.1 of a CPU, and you have a pod B that requests 0.6 of a CPU, That's a total of 0.7, right? So now you're saying, well, the entire namespace can only have, in our case, one CPU. And the same goes for memory. So in our case, we said, hey, the total maximum for each pod, all summed together, not for each pod, for every pod summed together can be 2 gigabytes. And that's what we're looking at here. Limits are the upper bound of what all of the pods can use. So if requests are essentially a pod can request how much CPU it needs, but that is the absolute minimum that it's going to use, right? But then a limit is something where it can go up to a certain amount of CPU. So for example, it can request 0.1 or 0.01 of a CPU, but then it can go up to say 0.5, for example. This allows limits and requests are a crucial and an important part of defining your cluster because it allows you to control how much CPU every pod uses. For example, you may have jobs that are doing a lot of processing inside your cluster, but you don't want your web UI that the customer is using to suffer, right? So you would request a minimum amount of CPU and memory that you need for that web UI to function well for the customer, whereas everything else that's running in the cluster will use all the remaining resources. In this case, what we're setting is we're setting a resource quota for the entire namespace. So the total number of CPU and memory that all the pods put together can use. So these are resource quotas. Next, limit ranges define the individual settings for each pod. So you can see here that we have something called limits, and then inside we say, hey, the default limit for a pod is 300 M. And the default limit is 256 megabytes of memory. So if we're defining a deployment or a job or anything else that's running inside our cluster, and we do not set a default limit inside the definition file, we'll get there in a future video. If we do not set that, this is what it's going to get from this limit range file right here. Same goes for requests. So the default request, if we do not set it in the deployment, it's going to get a default of 0.01 of a CPU, right? This is 10 M, so 0.01. And the same goes for the max and the min. Now that we have written these files and I've described them to you, one thing actually I'd like to point out is that here I used variables from the values file, and here I did not. This is just to demonstrate. Typically, I would actually move these over to the values file, but I wanted to point out that if there are things that are not going to change or that you're not going to be passing in through the command line. So for example, all of these values can be overwritten when you say Helm install. You say Helm install -- set, and you can say namespace, and you can pass in a string to make the namespace called something else. But if you're not expecting to change certain things inside your cluster, they do not need to be a variable. And I would urge you, for the sake of simplicity and readability of your template files, to not set everything to be a variable. Not everything needs to be a variable. All right, but now that we have all of this in place, let's switch back to the terminal and let's install this Helm chart. Now back in the terminal, we're going to use Helm to install this chart. Now, if we just type in Helm, you'll get a whole dump of things you can do with Helm. But I'm going to just give you like the raw command that you need to install this Helm chart. All right, so since we are in this folder, which we can see here that we have these files. We have the chart, the values file, and everything. All we got to do is we got to say Helm install. Then we got to give the name of the installation. In our case, we are installing the cluster definition, right? So we're just going to call this cluster. And then it wants to know where the file is. So since we're already in that directory, all we got to do is just put dot, because we're already in the directory, right? That is it. Now there are other flags that you can add, and you can kind of see here that for each one of these you can say --help, and it'll give you like more things you can do. But the simple way of doing it is just say helm install name and then location of the file. So let's press enter and see what happens. And well, there's not much going on in here. All we're doing is we're creating a namespace. So this was like super fast, but you can see here that we deployed a cluster, and there's one revision and the time that was deployed, and that's it. So if we want, we can say helm list, and it'll tell us that we have one deployment that's deployed to the cluster. Since this is just a namespace, we can see using kubectl what kind of assets we have. So if we say, for example, we had a config map, right? So we can say kubectl get, and then we have ns. So if we get ns, so we see that we have the homey namespace right there. And we have other things. So we can say get, and then we say config map, and then we need to say -n homey. Now we're not using kubens just yet. We're going to do that in the next video. But kubectl get config map, and you can see that we have a global config, which is what we had in our Visual Studio earlier. We have installed all of our assets, and if we start up K8s and we go to 0, we see that we don't actually have anything here yet because we haven't actually created any deployments or services or anything like that. So in the next video, we're going to use the two other tools that we've installed, which is kubernetes, and actually we're not going to use kubectx because we only have one context right now. But we are going to install Postgres, and we'll be able to see it come up here in K8s. Hope that was useful, and stay tuned. We're going to build the whole cluster in the next series of videos. See you there.